Good morning friends. Today we'll describe about the hybridization. What hybridization mean? Hybridization is the intermixing of atomic orbitals to produce the molecular orbitals. The among various principles for hybridizations, the most important one is that the number of atomic orbitals participated in the hybridization is equal to the number of hybrid orbitals. So the number of atomic orbital participate in the hybridization is equal to the number of hybrid orbitals. Suppose two number of atomic orbital participate in the hybridization, then two number of molecular will be emerged. So now in this concise video we will describe about the simple tricks of hybridization. Simple tricks of hybridization. So before that we have to be able to draw the structure of various molecule. This is called Lewis dot structure. Lewis dot structure. How to draw the structure of molecule using the Lewis dot formula we will discuss in some next video. So let us draw some of the molecules using Lewis dot structure. For example, this is the water molecule and this is the ammonia molecule and this is the methane molecule. This is the beryllium chloride molecule and this is the carbon dioxide molecule and this is PCl3 molecule and this is sulfur dioxide molecule. So let us for this examples molecules, always whenever we speak about the hybridization, we speak the hybridization of the central atom of a given molecules, because in the central metal atoms some orbitals participate in the hybridization to produce the molecular orbitals. Why this hybridization takes place? In order to gain stability. Everything in the world what happens, there is the inherent tendency to gain the stability by some means. So in that way hybridization is one of the method to gain the stability. So in this water, oxygen is the central metal atom. In ammonia, nitrogen is the central atom. In methane, carbon is the central atom. In beryllium chloride, beryllium is the central atom. Carbon dioxide, carbon is the central atom. PCl3, phosphorus is the central atom. Sulfur dioxide, sulfur is the central atom. Now we assign the lone pair also. In water molecule, 2 lone pair. In ammonia, 1 lone pair. In carbon, no lone pair. In carbon, no lone pair. Here 1 lone pair. Here 1 lone pairs. So you need not to be worried about this assignment of this lone pair. It is all about the Lewis dot structures. Now we have completed the assignment of lone pairs and bond pair. Now we will count. The art of count. Art of count will lead to the speaking of hybridization. If you know the art of count, count of what? Lone pair and bond pair. Among the bond pair, there are two bond. One is sigma bond, one is pi bond. Sigma bond and pi bond. Whenever we will count the bond pair, we will always count the sigma bond, not the pi bond. So what we will count? Conclusion is that always we will count the lone pair and sigma bond. So there is no need of any confusion. Whenever there are more than 2 bonds are present. One is sigma bond, one is pi bond. So always we have to count the lone pair and sigma bond. In this water molecule, 2 sigma bond and 2 lone pair. So in total 4. In ammonia, 1 lone pair, 3 sigma bond. So total 4. In methane, there are 4 sigma bonds. So total 4. Here 2 sigma bond, lone pair. So here 2. In carbon dioxide, 1 sigma, 1 pi. 1 sigma, 1 pi. So in total there are 2 sigma bond, because we have decided not to count the number of pi bonds. Here 1, 2, 3 sigma bond and 1 lone pair. So total 4. In sulfur dioxide, 1 sigma, 1 pi, 1 sigma, 1 pi and 1 lone pair. We will not count the number of pi bonds, only the sigma bonds. So 2 sigma bond, 1 lone pair, so 3. So based upon these 4, I will assign the hybridization of oxygen in water as sp3, because this 4 is made by the intermixing of 1s and 3p orbitals. Here also this is sp3, intermixing of 1s and 3p. It is also sp3. Here 2, that means 1s and 1p. Here 2, that means sp hybridizations. Here 4, that means sp3. Here 2, that means 2, 3, that means sp2. Because from the concept of orbitals we know there are 4 types of orbital: s orbital, p orbital, d orbital and f orbitals. In whatever the molecules we have discussed, here only the participation of s and p orbital takes place, because we know 3 p orbitals are there and 1 s orbital is there. So when we require more than 4, at that time the requirement of d orbitals occurs. Here we have discussed up to the 4, that is why with the participation of s and 3 p orbital, it is possible to produce 4 sp3 hybrid orbitals. So this is all about some simple tricks about the hybridizations. In the next video, we will describe about some other hybridizations of the central atom of the various different molecules. Goodbye.